Yeah, hi there. In this tutorial, we are going to cover Pandas query function. So the query function in the Pandas is a useful function that acts similar to the where clause specified in the SQL queries. It is particularly helpful for the people who are coming from the SQL background. So instead of using dot lock or dot ilock method to filter out the rows, they can use this query function, which will provide them the similar look and feel, the way to filter the data like they have been doing it in the SQL. So the syntax to specify this function is it is like data frame dot query, and then we specify the function expression as the first argument, and then it is in place, which is by default as false. So the expression is actually some sort of a logical expression that describes which rows to be written in the output. So the rows for which this expression holds true, only those rows are written in the output. If for any row this expression holds false, then that row is excluded in the output. And we specify expression by enclosing it in the quotes, either single quote or the double quotes. In place equals to false is the default way, that is the output will be in a form of a new data frame. However, if you want to make changes in the existing data frame, then we have to specify in place equals to true. Usually we don't specify in place equals to true in case of df.query. The reason being we want to keep the original data frame intact, and based on the condition that we're specifying using the expression, we get a subset of our data frame. Okay, so let's continue. We read a file called employees.csv, storing it in a data frame emp. Let's check the shape. It says it's 1000 rows and 8 columns. Let's checking at the first three records. So we get these three records. So these are the 8 columns: first name, gender, start date, last login time, salary, bonus percentage, senior management, and team. I'm just quickly checking at the data types of the columns of employee data frame using .d types, and then I'm just doing a, a calculation of how many null values are there in each of the columns of the data frame using .sna and .sum. So we see that okay, 145 145 data points are missing for gender and 67 for senior management. For team, there are around 43 records in which there is no value, or it's a missing value. Okay, so one thing to note while using the query is it has a limitation in terms of what the column names we can specify. So a rule of thumb is if if there is a column name that is not a valid Python identifier name, then it probably will not work. In that case, we have to enclose it in back quotes. So in this case, if you see the column names have a space in it, for example, first space name and last start space date. So what I'm going to do is I'm going to replace space with underscore. So using emp.column, so str.replace function, I'm just replacing the space with the underscore and storing it back in the column names, and just checking the first three records again. So this is how our column names look like. So now let's start using the query function. So our first query is select only those employees who are in senior management. Okay, so basically we want to select only those employees where senior management is true. So how do we do this? So following our syntax, so we have to first specify the data frame. Data frame is emp, so we say emp, then dot, then query. So this is as per the syntax. Then we have to specify the expression. So expression is senior management equals to true. This is the expression that we have specified, and we have to enclose this expression in double quotes or single quotes. So that is why this is enclosed in double quotes, and I'm selecting the first 5 rows, so using dot head. So in the output we'll see only those records where the senior management is true. So let's move to the next query. Now we have a two condition. One is I want the first condition is that that the senior management must be true, and the second condition is that the team is the marketing team. So basically we want to see only those employees who are in the senior management of marketing team. Okay, so we have two conditions here. Again, just following our syntax, we will use emp name of the data frame dot query, then bracket start, and within double quotes, the first condition is senior management equals to true. So this is the first condition, and then we have to join this condition with the second condition. So using this and logical operator, and the second condition is team equals to marketing. So team equals to marketing, and again I'm just using head to select the first five records. So if you see in the output, you will get only those records where the senior management is true and all those employees who belong to the marketing team. Okay, now one another thing we can do is if we already have a predefined Python object like a list or dictionary keys or a set, something like that, or an individual variable, then we can refer to that within our uh, query string by preceding that object by at the rate. So let's say we have a team list. So basically, it's a list in which the team names I have specified. These are marketing, sales, and finance. And I want to see all those employees who belong to the senior management and who are in any one of these teams. So how do we specify this query? So emp.query, that's the data frame.query. Now within double quotes, our expression will go. So expression is team in. So team is the column name. Team in at the rate team list. So you see this is the team underscore list. It's a Python object that we have already created right there. It's a Python list. So to use it within our df.query or data frame.query within the string, so we have to precede it by at the rate, and then we can use it. So team in. So if so, the column team has a value which is within this list and senior management equals to true, then only return those records. So that's how it will work. Okay, let's say our next query is find the employee who got the maximum bonus. Okay, so again outside the query I am just calculating the maximum bonus using np.max and storing it in a variable max underscore bonus. Now again our query becomes like this. So emp.query, and then within double quotes we specify the expression like name of the column, which is bonus underscore percentage. Now if you notice that this particular column has percentage in its name. Now this is not the usual way how we specify the Python object, how we name a Python object. So we have to put it within the back quotes, otherwise it will give error. So this is how we specify the column name, which is not following the principles of creating any variable name or any literal name within the Python. So just put it within the back quotes, and then just comparing it with the at the rate max bonus. So we are specifying at the rate because we are using a object which is already predefined. So it will return that employee who has got the maximum bonus. In this case, Robert, he got the maximum bonus and he is from a legal department. Fine. Now find all those employees who were hired in the same year when the oldest employee was hired actually. So I want to find out first what is the year of the oldest employee. So what I'm doing is using pd.toDate time, because start underscore date we saw earlier that it was object type, so not in the date time format. So we have to use pd.to underscore date time to convert it into date time format, and then using .dt .year we can find out that particular year for that particular column. And since we are interested in finding out the oldest year, I mean employee who was the oldest in terms of when he was hired. So for the year we'll give minimum. So that's the oldest year. So we got that. Okay. So the 1980 was the year when the employee was hired oldest. Now, so we got this year. Now we have to select all those records in which start underscore date is like 1980. Now we know that start underscore date is like is an object which is like in a string. So how do we specify it? We cannot use like we use in Oracle. We specify like. So here it is not available. So the another way to do it is like this. So the data frame dot query, and within double quotes we specify the expression is start underscore date. That's the name of the column. Dot str dot contains 1980. So any record in which start date contains 1980, that particular record will be returned, and we are selecting the first five records using the head. So if you see only those employees who were hired or who actually started their job in the same year when the oldest employee was hired, or when the employee at the earliest was hired, then it's the same 1980. All those employees will be returned. Another example we are going to cover is how to find out the records where any value is missing. So eh, we see the team particular team column has some missing values. Let's check for that particular column. So emp dot query, and within quotes we specify the expression team dot is null. So all those records where there is a missing value for team column, those will be returned. Now we can again join it. Let's say we want to see all those records where team as well as senior management information is missing. That is, both information are missing. So emp.query team.isNA, and the second condition is senior management.isNA. So all those records where team is NA, that is missing, and senior management is also missing. So those records will be returned. Now we can also select records based on a specific year. Let's say our query is to select all the records when the employee were hired in a specific year, let's say 2010. Now we know that the start underscore date is in the object format, not in the date time format. So first what I'm doing is I'm converting it into date time using pd dot to underscore date time. So it will convert the start date into date time format. Then I want to sort the data frame based on the ascending order of the start date. That is, employee who was hired earliest should appear first in the data frame, and the employee who has been hired latest, that is whose start date is latest, should appear at the bottom of the data frame. So I'm just sorting the data frame emp.sort underscore values using start date, and in place equals to true. So it means the actual data will be sorted within the data frame. Now I'm just setting start date as an index. So now because our data is sorted based on the index, it makes sense to just set start date as the index of the data frame. So I'm just setting it using dot set underscore index. And this is how our data frame now looks like. Now our query is to find out all those employees who were hired in a specific year, say 2010. So our query is like this, emp.query. Now in this case, we don't have to necessarily specify that particular, now because start date is what it is, it's an index. So we can say index dot dt dot year. So index refers to start date, and from this particular values of this particular column, I'm extracting the year using dot dt dot year and comparing it with 2010, and selecting all those records and just displaying it only the first five using the head function. So in this way, we'll get only those records where the year is 2010. Let's say another example is find out all those employees who have completed 35 years of service. That is, we know their start date and we know the current date, and I want to find out all those employees who have completed 35 years of service. That is, current year minus the year when they actually started should be greater than equals to 35. Yeah. So how do we get the current year? So I'm just using date time. So from date time import date, and using date dot today dot year, I will get the current year. Now this is our variable which we will refer in our query. So I'm just saying emp dot query, subtracting from current year, I'm subtracting the year for each of these values. So how do we get the year for each of these values? Index dot dt dot year, and wherever the difference is uh, let's say more than 35 years, so greater than 35, it will return true, and we are displaying those records. So all those employees who have more than 35 years of service, those will be returned by this query. Another thing we can do is we can change the query. Let's say we have a very complex query in which we can, it will be, let's say in which it is difficult to specify all the conditions in a single query, then we can change it using emp dot query, then specifying the first expression in, and then again using dot query, we can specify the second expression, dot query, again another expression, and so on. So let's say in this case, what I'm doing is I'm just specifying the first query as from the employee, select all those employee who belong to sales team, and the gender is female, and they belong to senior management. So it's like it's equivalent to saying that all those employees who are female and in the senior management and from the sales team, give me those employees. So it can be directly, all these conditions can be put in a single query also by joining it with the and, or we can just segregate it or chain it using this method. Another example of chaining is, let's say I want to find out the mean salary of the employees who work in the sales department. So I'm doing emp.query, specifying the expression team equals to sales. So it will return all those employees who are in the sales team. And so once we have this, I'm selecting only the sales salary column, and then I'm applying the mean function to it. So this is the mean salary of all those employees who work in the sales department. So that's it in this tutorial. Thank you.